Let's logic unit here. Okay, so we're going to talk about what a conjecture is. So it's you making predictions. That's kind of what a conjecture is. You're going to make predictions or draw conclusions. Okay, in inductive reasoning is when you conclude based on observations or patterns. Okay, deductive reasoning is when you conclude something and you're going to be based on facts. Okay, so there's scientifically you can prove that that's true. Somehow you can prove it's true. Okay, you ready? Number 1. I have an example here that says 4 times 2 is 8, 7 times 2 is 14, 13 times 2 is 26. Can you make a conjecture about what's happening? So does anybody know what was the same thing that I was doing? What did I do the same in all of those? I was multiplying by 2. Then I was switching numbers. So could we say any number multiplied by 2 based on your observation, do you have a conclusion of what's going to always happen?
It's
Doubled, even. The result will be even. Okay? That's my predictions that I'm making based on what I'm finding. I'm drawing a conclusion of what's happening. A soccer tournament organizer bought 100 small, 200 medium, and 100 large t-shirts to sell. What conjecture could you make? Okay. Anybody notice anything specific here? What do you think?
The amount of medium is the same amount of small and large.
The amount of medium is that added up?
Yeah.
Okay. Here's probably what I would draw as a conclusion as an organizer. The medium size is probably the most popular size. Is that a good enough conclusion? Medium is most popular size of shirt. Okay, nothing to do with math related, I guess, facts, but understanding a conclusion. Mrs. Falk arrived at school at 8:30 on Monday and at 8:30 on Tuesday. Therefore, Mrs. Falk always comes to school at 8:30. Okay? When I did my conclusion, did I base that on inductive reasoning or deductive reasoning? Inductive, because I concluded that based on just something I observed. Is it always true? Do I always come to school at 8:30? Probably not. Sometimes I come at 6:45 when I have volleyball practice, right? It's not always true. It's just, so that's an inductive reasoning. A square is a rectangle. Did you know that? A square is a specific type of rectangle. A rectangle has 4 sides, therefore a square has 4 sides. Okay? Did I make this conclusion based on observations or facts? Facts. So this is deductive reasoning. Okay, number 5. The sum of an odd number. So this in math is an odd number. 2x, 2 times anything, and if you add 1 to it, it becomes odd. So the sum of an odd number and an even number, and then when I rearrange that, I GCF'd a 2 out, but there was still a 1 left. So I'm showing you that the sum of an odd number and an even number will be odd. Did I show you using inductive or deductive reasoning?
Deductive.
Deductive. If I did this, to you and made the same conclusion, that would be called inductive reasoning. If I said, look, an odd number plus an even number is odd. Odd plus even is odd. Odd plus even is odd. If I showed you using examples, this would have used inductive reasoning. Okay? But in 5, I showed you using deductive reasoning because this is proving it is always true, right? Does that make sense to you in math? An odd plus an even will always make odd. That is true. Okay, I'm not sure, does this jump a couple pages? The validity of a proof, does it jump to page 3 or something? The validity of a proof. Okay, so we're going to use counterexamples, and it would be something that shows it's not, I should say, not always true. Okay, so in example 1, they did 4 squared is 16, okay, that's true. 1.5 squared is 2.25, that's true. Thus, I'm concluding, if you square a number, it will get bigger, right? If I square 4, the result is 16, and that 16 is bigger than the 4, okay? Obviously, I'm making this using inductive reasoning, right? Because I just based my conclusion off of a few examples. Is this true in math?
No.
No. So is it valid? No. Can you give me a counterexample that shows me it's not always true with a number? What do you think, Erica? If you square 1, it's 1. Did it get any bigger? No. There's a couple other things you could have used.
If you square 0.2.
0.2 squared, it should be 0.04. It got smaller. So 1, fractions or decimals, and there's also another number when you square it. 0 squared is 0, right? So that doesn't show it gets bigger. Okay. Sometimes when we try to make logical statements, they don't make sense. So why might they not make sense? A false assumption. A false assumption would be when you start a statement with something that's not necessarily a fact. An error in reasoning. You could make an error in calculations, or you could use faulty logic. Okay, so I'm going to write this down. An error in reasoning is you didn't really connect your ideas well together. Okay, and faulty logic is when you read it, it probably just doesn't even make sense at all. They're not really logically connecting anything. Okay, so example 2. This is what somebody did. They made the statement, all girls have long hair, Linda is a girl, therefore Linda has long hair. What's wrong with what that is saying? Okay, so what is the wrong part about it? So use one of these. Did they make one of these happen? They made a false assumption. Okay, that is not true. All girls have long hair. That's just not true.
My brother has long hair. Does that make him a girl? It's like a homeless man.
Okay. Cats are mammals. Mammals have warm blood. Therefore, cats have 4 legs. Yikes, that doesn't really conclude what we want it to.
Is it an error in reasoning?
I would say it's faulty logic.
It's because, well, cats are mammals.
Cats are mammals. Mammals have warm blood. Therefore, cats have 4 legs. What does 4 legs have to do with anything?
Yeah,
Right.
because, we're mammals. We don't have 4 legs. You have 2
What could you conclude? Cats are mammals. Mammals have warm blood. Therefore, what can you conclude? Cats are mammals. Mammals have warm blood. Therefore, cats have warm blood. That's what it should be. Okay. A Mercedes-Benz is a luxury car. Okay, that is true. It's not a false assumption, that's true. Jake drives a luxury car. Therefore, Jake drives a Mercedes-Benz. Is that true? No. So, is it he kind of had the right idea but didn't really put it together right? So the reasoning was not good. What is the problem with his reasoning? So Mercedes-Benz is a luxury car, and Jake drives a luxury car. Therefore, he drives a Mercedes-Benz. What's wrong with it?
Mercedes-Benz isn't the only luxury brand.
It's not the only luxury car. So Jake could have drove a Corvette or whatever, right? Porsche. So that's the error that was made, an error in the reasoning that was trying to make those connections but forgot, like, hey, there's other types. This could have concluded something else.
Yeah, you could say that I'm eating a banana. That's true. So I'm eating a berry. Bananas are berries. And so then I'm eating a banana, but I'm eating raspberry. It's
Yeah.
not the same
Not the same. Okay. This person took a number, increased it by 4, multiplied it by 2, then increased it by 6, divided by 2, and the result was 5 more than the original number. Something happened. What happened? So, ready? I took a number. Is that good? Take a number, n. Then they increased it by 4. Does this make sense? Then they multiplied by 2. Does this make sense?
No.
Doesn't make sense. What happens if you multiply by 2? That would also have to change to 8. You would have to do it like that, right? Multiply brackets that number by 2. So, therefore, what did they do when they were making their conclusions? They did a error in calculations. So, on the test, here's what I'm going to do on that question. I'm going to have 4, and you have to match them. Okay?